In this video, you will learn when to say that a function is odd or even. Basically, there are two ways to say that a function is odd or even. First way is graphically, which will be explained in this video. Second way is algebraically, which will be explained in the next video. So before to start, there are some properties we have to consider them. So we will use those three properties to determine whether a function is odd or even or neither. Neither means it is not odd nor even, okay? So first case is odd function, symmetric with respect to the origin. 0 is 0 on x-axis and 0 here is 0 on y-axis, okay? So it will be like that. Here it is symmetric with respect to the origin. The origin means at this point, okay? So we see that our curve cross or pass from this origin point, 0 on y-axis and 0 on x-axis, and it continues. Then we see that this part is symmetric with this part, right? So this means it is odd function. Second case is even function, symmetric with respect to the y-axis. So if we see the graph, we see that this graph from here, this is y-axis, right? So we see that this part is symmetric with this part with respect to y-axis, right? So this is even function. Third case is neither. Neither means it is not odd nor even, okay? So no symmetry with respect to the y-axis or the origin, okay? Y-axis or the origin, meaning this graph is not odd nor even. Why? First we check, is it even? So we check from here, this is y-axis, okay? We see that this part is not symmetric with this part. With respect to y-axis, you see one curve goes up and one to down. So they are not symmetric, right? So not even. Then we will check, is it symmetric with respect to the origin? So is it symmetric with respect to the origin? So you check, this is the origin, 0. So you see that this part is not symmetric with this part, right? This is too small, this is too large. So it is not odd also. Let's see our first example. Determine if the following graphs are odd or even or neither. So this is our function, this is the graph of this function. So first we see it is obvious from here, we see that this is y-axis, okay? So you see this one part, second part, they are exactly the same, they are symmetric. You see this part is symmetric with this part with respect to y-axis. So it is even function because the graph is symmetric with respect to the y-axis. Let's see this graph also. So we see that it does not cross the origin, right? So we check, is it even? So you see that from here, this is symmetric with this, right? With respect to y-axis. So it is even, okay? Even function because the graph is symmetric with respect to the y-axis. Let's see our second example. Determine if the following graphs are odd or even or neither. So this is the function, this is the graph. So this is y-axis, right? So obviously you see that this part is symmetric with this part with respect to y-axis, okay? So it is even, okay? Even function because the graph is symmetric with respect to the y-axis. Now coming to this one, again we see that this graph does not cross the origin as this, or you can see also. So we see that this function didn't cross the origin and it is symmetric with respect to y-axis. This is the same case. We see that it does not cross the origin here, and it is symmetric with respect to y-axis. Why it is symmetric? Because this is y is equal to cosine of x. Cosine of x is always something is doing like waves between 1 is here, and minus 1 is here, okay? And it is always the same, it has always the same waves, we can say. So we see that this part from here is symmetric with this part from here, okay? So this is even function. Why? Because the graph is symmetric with respect to y-axis, okay? Let's see our third example. Determine if the following graphs are odd or even or neither. So from here we see directly that this curve cross the origin here, 0 here, 0 on y-axis and 0 on x-axis. Then we see that this part is symmetric with this part, both of them with respect to the origin. So it is odd function, okay? Odd function because the graph is symmetric with respect to the origin, okay? Let's see this example also. This is y is equal to sine x. Sine x, it is close to the cosine of x, but the only difference is sine x, now it is passed from here, from the origin, okay? And we see that this part here is symmetric with this part here, right? With respect to the origin. So this is odd function. Why? Odd function because the graph is symmetric with respect to the origin, okay? Let's see our fourth example. Always the same. Determine if the following graphs are odd or even or neither. So we see from here that our graph crossed the origin, okay? And we see that this part here is symmetric with this part here with respect to the origin. So this graph is odd, okay? So odd function because the graph is symmetric with respect to the origin. Let's see this one. We see that it does not cross the origin, but this part is symmetric with this part with respect to the y-axis. So this is even function, okay? So even function because the graph is symmetric with respect to the y-axis. Let's see our fifth example. The same. Determine if the following graphs are odd or even or neither. So in this case here we see that our curve does not cross the origin, so it is not odd. Second thing, we see that this part is not symmetric with this part, right? With respect to the y-axis, right? So it is not even also. So hence neither, because the graph is not symmetric with respect to the y-axis to be even or the origin to be odd, okay? So it is neither. Let's see this example also. Y is equal to 2. This is a constant function. For a constant function, it is always like this line. It is a straight line, okay? So this is a general rule for any constant function. We call it even function, okay? so it is always even. If you had, for example, y is equal to 3, y is equal to 4, this is always even function. Let's see our sixth example. Determine if the following graphs are odd or even or neither. So from here we see, in this case, we see that our curve crossed the origin. Then we see that this part is not symmetric with this part, right? So it is not odd. Is it even? We can check. So we check, is it even? So you see that this part is not symmetric with this part with respect to the y-axis. Okay, you see one goes up and one goes down. This is too small, this is too large. It is not symmetric with respect to y-axis. So it is not even also. That's why it is neither. Okay, neither because the graph is not symmetry with respect to the y-axis to be even or the origin to be odd. Okay, let's see this graph also. So here it is obvious. Directly you can say it is neither. Why? Because you have only one part. You don't have any opposite part to say it is symmetric or not. Okay, so you directly say neither because the graph is not symmetry with respect to the y-axis. You don't have any opposite part, or the origin, it just starts from here to infinity. Okay, in the next lesson we'll talk about how to find a function, how to say if a function is odd or even using algebraic techniques. Thank you for watching and hope to see you in the next video.